Hello everyone and welcome to this video. Today we are going to talk about limiting reagent. Also in many books you will find it as mentioned as limiting reactant also. Okay. So what is basically this limiting reactant or reagent? What are some properties? Let us see. This limiting reactant is the one which will be consumed earlier in a chemical reaction. It will be finished earlier or consumed earlier in a chemical reaction. For example, let us do this dummy reaction A plus B plus C and we are getting ABC. Let's say this B is like finished earlier. It's like ended, finished. So this B is the first one which is finished. So this will be your limiting reactant or reagent. Okay, so this is consumed earlier. Second point, this limiting reagent is the one which will control the amount of product formed. Like how much product you are going to get, who will control it? It will be the limiting reagent. How? Let's say this B is finished here. If this B is finished, then you will see that this ABC cannot be further formed. It is finished. Third point, it is also expensive one. The limiting reactant is expensive as compared to the others one. Okay, now let us see a question, like let's an example how we can find this limiting reagent. Okay, we have an example in which we say that we are manufacturing phosphoric acid with the help of phosphorus, oxygen and hydrogen, of water. So the quantities are given to us and we want to see out of these three which one is the limiting reagent. In a stoichiometric calculative question, like a stoichiometry question, two things are very important. First thing, if you have a balanced equation, and second thing, you have the quantity, then your question becomes easy. Here we have the equation also and we have the quantities also. Okay, let's start this question. We have three reactants and we want to calculate the limiting reagent. It is not true that the one which is present in lesser amount is your limiting reagent. Sometimes the quantity needed in a reaction is also less. So we have phosphorus, we have oxygen, and the third one is water. If you see here, it's given that water is in excess. Excess means it is extra, more. So something is extra, cannot be consumed earlier. So water goes out of the race. Now we have two, phosphorus and oxygen, and we want to see which one of these is the limiting reagent. First thing, this is in grams. The quantity which is given to you is in grams. What we need to convert it into moles. And how we can do it? Again, we can use given mass over molar mass formula. So we have 24.77 N is the symbol for moles, which is now we need the masses of phosphorus and oxygen which we can get from the product table. So it is 4 because we have 4 atoms, so 4 into the mass which is 30.97. you can get it from a product table, and this one is 100 over 2 into 60. This will be how much? You will solve it, it will be around 0.2000, and when you will solve this, this is around 3.125. So this is the quantity in moles. We have the quantity in moles. Now next thing we need is that we should have the equation. To get the limiting reactant, we need is the equation. Let us write here. We have P4 plus 5O2 plus 6H2O will give you 4H3PO4. Make sure your equation is balanced. If you don't know how to balance equations, first go to the video of equation balancing and check it, because you need to understand the importance of equation balancing in this stoichiometric calculations. Now you see here, according to the equation, we can see from the equation that if you have 1 mole of phosphorus, if nothing is there, it means 1. If you have 1 mole of phosphorus, it is reacting with 5 moles of oxygen in this, right? You have 1 mole and it is reacting with 5 moles of oxygen. Okay, this information you get from the equation. Like, to make this product, 1 mole of phosphorus should react with 5 moles of oxygen. But the point is, you don't have 1 mole. You have how much? You have 0.2 moles of phosphorus. You have only 0.2 moles of phosphorus. Now you want to find, like, for 0.2 moles of phosphorus, how much oxygen you need. You don't know, so you put an X here. You put an X here. What is this? This is the quantity we have. Like, from this we get from the equation that 1 mole needs 5 moles of oxygen, but we don't have 1 mole, we have 0.2 moles. So 0.2 moles we need how much? We don't know, so we put an X. Now do simple math. This is like a direct proportion question. Do the cross multiplication. You will get what? X is equals to 5 into 0.2. So you need only how much? 1 mole. This means what? That for 0.2 moles you only need 1 mole of oxygen, but you have how much? You have 3.125 moles. So it means you have extra oxygen with you. You have extra oxygen because you need only 1 mole for 0.2 moles of phosphorus, but you have 3.125 moles. So you have extra 2.125 moles. So which one will be consumed earlier? Phosphorus is the one which will be consumed earlier. So which one is your limiting reactant? Limiting reagent is which one? Phosphorus. You can do it opposite also. Like, if you don't want to do it with phosphorus, you can do it with oxygen also. Like, 1 mole is needing 5 moles. You have 3.125 moles. So you can put here 3.125 and you can put here an X also. So you will see that you need additional phosphorus for this. You will get that phosphorus is short. So this is the way how you can calculate the limiting reagent. Next, one more thing is asked in the question, that is to find the theoretical yield. Okay, theoretical yield means the output. Theoretical yield means the output on the paper. Like on theory, how much output you will get. Again, for this you need the equation first. P4 plus 5O2 plus 6H2O will give you 4H3PO4. To find this yield, first you have to find the limiting reactant. Without the limiting reactant you cannot calculate the yield, because limiting reactant is the one which will control the amount of product. So we need to know the limiting reactant. We have calculated here the limiting reactant, which is phosphorus. So now we know that this phosphorus is the one which will control the product, which is this product. So we know we have phosphorus and we have the acid, phosphoric acid, the product. Now we know 1 mole of phosphorus is giving you how much moles? 4 moles of phosphoric acid. So you have how much? You have 0.2 in your stock. So it will give you how much? X. Again, do the cross multiplication. You get X is 0.8 mole. So you will get 0.8 moles of the product with this quantity. You want to find the mass in grams of phosphoric acid, so you can use the same formula, which is number of moles is given mass over molar mass. So this is 0.8 is given mass over the molar mass. You can calculate from the product table. You will multiply with this, you will get your given mass here. Okay, thank you so much guys. See you next time. We will talk more in one more video about the yield, the experimental yield, the theoretical yield, and how to calculate the percentage yield. Thank you guys.